Guys, graphing cube root functions, you've been working on page 312. Let's make sure we understand what a cubed root is. And in order to understand a cubed root, you need to know what perfect cubes are. So if I were to say, actually let's write it over here. If we have x, then x cubed. Okay. If I start with negatives, and I'm going to actually start with negative 4. Negative 4 times negative 4 times negative 4. That's what we're doing right here. What's a negative times a negative times a negative? Negative. It is a negative. So the first difference between square roots and cubed roots are that you can actually have negative cubed roots. Okay, so if I cube negative 4, I get negative 64. If I take the cubed root of negative 64, which is what I would be doing right here, the cubed root of a negative, that's saying what number times itself 3 times, and for that matter, anytime you have a number up here where the square root usually doesn't have something, that's saying how many times am I multiplying something by itself to get the thing in there. So a negative 4 times a negative 4 times a negative 4 gives you a negative 64. That is the cubed root of negative 64. It's negative 4. So one difference between square roots and cubed roots, you can have negative cubed roots. You can have a negative on the inside. In fact, any odd numbered root, you can have a negative on the inside. Any even number, you can. Okay? Tell your neighbor why that would be. Why could you have, for even numbers, why couldn't you have negatives on the inside? And for odd numbered roots, why could you have negatives?
Because
Times all these.
It's very true.
Times.
It's good thinking. Hey, you guys, it's negative times negative. As Jonathan was saying up here, negative times negative is a positive. Negative times negative times negative is a negative. Okay, if you have an odd number of negatives, you would get a negative answer. An even number of negatives will always give you a positive answer. Yeah?
Couldn't you just take out the negative sign, solve it, and then put the negative sign back?
You could, yeah. If you're trying to find the cubed root of negative 64, you could take out the negative sign, figure out what it is, and put it back in. Yeah. So if I had negative 3, negative 3 times negative 3 times negative 3 is negative 27. That means the cubed root of negative 27 is negative 3.
Wait, so like if it's odd, it can't be negative?
If the power is, if this is odd, it could be a negative. If this is even, like square root, would be like the second root, you can't have a negative there. Has nothing to do with what number we're putting up here. So if I say negative 2 to the second power, that's 4, because negative 2 times negative 2 is 4. But negative 2 to the third power makes it negative 2 times negative 2, which is 4, times another negative 2, which is negative 8. Okay, so the cubed root of negative 8, okay, I shouldn't have x there. The cubed root of x cubed is what that is, okay, is actually negative 2. Okay, so the cubes that we're looking at here, these are our values. That and that, that and that, that and that. Negative 1 would be, negative 1 to the third is negative 1. What's 0 to the third? 0. What is 1 to the third? What is 2 to the third? It's 8. We're kind of going the other way, right? What's 3 to the third? 27. And 4 to the third? 64. Okay. Now look, you guys, these are your perfect cubes. Remember yesterday we graphed specific values? We graphed the parent functions. Okay, when you're doing a cubed root, there's a parent function involved. Okay, just like in square roots, we graph the ordered pair 0, 0. And 1 what? 1, 1. And then 4, 2. And then 9, 3. Okay, that was our square root function. With our cubed root function, our parent function that we're graphing is this function right here, the cubed root of x. And the way we get that is we pick perfect cubes. That's the easiest way. If I pick perfect cubes for x, if I pick perfect cubes for x, that would mean maybe like -4. When I put -4 in there, is that a perfect cube? No, that's not. What's a perfect cube that we should use there? 0? Okay, how about some negative perfect cubes? -1, -8. What's the cubed root of -8? Yeah, it's -2. Okay. So if I put -8 in there, I get -2 out. Because -2 times -2 times -2 is -8. What's the next perfect cube? -8. Go back to our list here. -8, -1, yeah. Cubed root of -1 is? It's -1. And I put -1 in right here for x, I get -1 out for y. Okay? My next input is 0. If I put 0 in here, the cubed root of 0 is? 0. Okay? My next input, let's say I put 1 in. I get 1 out. Next input, next perfect cube? 8. If I put 8 in, cubed root of 8? 2. Okay? Alright, so if I call this my parent function, I just graph those. I'm not going to fill out the rest of the table. Let's see what the parent function looks like. So we'd have -8, -2. -8, -2. We'd have -1, -1. We'd have 0, 0. We'd have 1, 1. And we'd have 8, 2. And we connect our points. This is kind of like a half parabola opening sideways there. And this one's kind of a half parabola open sideways there. That is our parent function. That's what it looks like.
That's cool.
Those are the points. These points right here are the ones you are going to graph every time if you're using patterns to graph. Because the patterns are identical to what we talked about yesterday. I'm going to ask you the same questions again. We'll summarize them a bit differently, but I'm going to ask the same questions. Okay? Remember, when you are doing transformations to graph these, rather than having to fill out a table every time, if I wanted to graph this using transformations, okay? Remember, our transformations, some notes to take down. What are the transformations we do to graphs? Good. Translation. Good. Reflections, shrink, and stretch. Well done. Okay. My line kind of varied off there. All right. Those are the different things we can do to a graph. All right. So remember, if it's with x, we call it horizontal. Okay? It's inside the radical with the x. It's happening on the inside in here somewhere. Okay? If it's outside, we call it vertical. Vertical happens on the outside. Okay? And from there, we can, the different types of transformation, it's a translation when you are adding and subtracting. Adding or subtracting, it's a translation. It's a reflection when you multiply by a negative. And it's a stretch or shrink when you multiply. One thing to keep in mind, everything that happens in the inside here is backwards. It's like counterintuitive. Okay? Everything seems backwards on the inside. So if we say we add, we actually move to the left. If we say minus, we actually move to the right. If we say we're times 2, we're actually, we're dividing by 2. Okay, everything's backwards. All right, so when I am dealing with this, the things that we need to start figuring out is like looking, everyone have that? I'll put it back up there here in a minute. But actually, maybe I'll just zoom out here. When I'm looking at this cubed root of x plus 3, first, is it horizontal or vertical? Well, happens on the inside, it's horizontal. This is going to deal with horizontal. And then, what type of horizontal? Well, you're adding. So which one is that? It's one of those. Looks like we're adding, so it's a translation. And usually when we add, we go to the right. However, it's backwards on the inside, so it's translation of 3 units left. What are we translating 3 units left? Well, we're translating our parent function, which was 0, 0, 1, 1, 8, 2, negative 1, negative 1, and negative 8, negative 2. We're taking those points, and we are translating them 3 units to the left. That means this point, actually let's start here, it moves 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3. And that point, 1, 2, well, it's way over there, so we're not even going to mess with it. Okay, if you want, it would be out here somewhere if you just want a point to help you graph it. So now when you're graphing them, you're just connecting all your 3's. Go out something like that. So the whole graph just shifts backwards 3 units. If you wanted to build your table, you could do that. It's just remember, you're trying to make perfect cubes. So if I want to make a perfect cube in here, and I'm adding 3, what plus 3 makes 8? 5. So x would have to be 5, because 5 plus 3 is 8, and the cubed root of 8 is 2. That means that the ordered pair, 5, 2, we should have a point, which we do. It's right there. What plus 3 is 1. Negative 2. So at negative 2, the cubed root of 1, negative 2 plus 3 is 1, the cubed root of 1 is 1. At negative 2, 1, there should be a point, which there is. Okay. Yeah, over here. So like this one. So on this one, let's keep going. If we said 0, we want to make 0 here. What plus 3 is 0? Negative 3. Negative 3, that gives us 0. Cube root of 0 is 0. Okay, so at negative 3, 0, we have that point. The next one is negative 1. What plus 3 is negative 1? Negative 4. That would give us the cubed root of that, which would be cubed root of negative 1, which is negative 1. And so that's right there. So that's what happens with the negative side. You can't keep working with your way there. Now, reality is I don't expect you to have to fill out this table if you graphed it using patterns, unless it specifically says fill out the table. The domain, does this graph ever stop expanding horizontally?
No.
No. So the domain is all real numbers. The range, does it ever stop expanding vertically? I mean, it looks like it flattens out. It's going up slower, but it never stops going up. Range is All real numbers. Arrows on both ends.
Infinity sign.
No, we're going to use all real numbers. No infinity signs. You know, it's kind of a cool symbol. Yes?
Is there ever a time when the double A isn't?
Not on a cube group. Okay, hey, we are going to skip the exploration number 2. Okay? But what I'd like you to do, so that's the page 313. If you want to spend some time on it, you can. What I want you to do tonight, there is page 315 of your student journal. I want you to complete those 6 problems. Okay? Use patterns to complete them. All right? Some questions? Okay. Hey, just so you're aware, on all of these, go ahead and just draw your X and Y axis like this. And go up by 1s. Okay? You don't have to go up by 2s or anything like that. If they just don't fit, they don't fit. Just go up by 1s.